So before we introduce you to our new word logarithm, we have to talk about inverses of functions. Inverse means to flip a graph over the line y equals x. It reverses the action of the graph. So you're going to learn that to take an inverse, you switch the x and the y places. Before we get into that, let's just look at a picture of it. We do have a new symbol to learn, where f of x meant function. Now to denote inverse, we say f to the negative 1x. Now that is not an exponent. Meaning you're not going to take f and make it into 1 over f, because this is function. It's not a number. It's not a variable. So to look at what an inverse looks like, we're going to go to Desmos, and they have a lovely little inverse applet. All right, so over here, I'm going to turn some things off for you first. There's the line y equals x. And now I'm going to make up a little cubic. There's a cubic. It's in black. And I can show you that there's a point traveling along the graph. Well, if I wanted to take the inverse, I told you we flip over that line y equals x. So you're going to get a mirror image over that. So there's our black point traveling along the black line. And now I'm going to give you, there it is, they're mirror images. Now you can notice at some points right here, see at the point 0, 0 they meet? Well, if you take the inverse, it means to switch x and y. So if I switch 0 with 0, it's going to be the same point. We can put in any function we want. Let's change this to just x squared. There it is. And there's our black point traveling along x squared. Now if we wanted to flip this, picture flipping this parabola over this line. What's it going to look like? It's going to look like that. And then we can travel. And notice there's the point 1, 1. There's the point 0, 0. Pretty cool. You can make up anything you want. We can make up just lines. There's 3x plus 2, and there's its inverse, and I can travel along. Ooh. It's kind of cool. Fun little applet to play with. But now that you got the idea of what an inverse means, let's play with it. So how do we create an inverse? Very simple. We just switch the x and y. So I'm giving you this function. If I was to write this in function notation, it would look something like this. If I want to switch x and y, all right, so I would come over here and let's do the inverse in blue. X equals 3y minus 10. See, that's exactly what I did. Instead of where there's an x, I write a y. Instead of where there's a y, I write an x. Now I can solve that for y because all functions are solved for y because x is the independent variable. So that would be x plus 10 equals 3y. Y equals x plus 10 over 3. And then if I were to write it in function notation, we simply take the y and replace it with that new notation, inverse. So we know these are related because this was f of x, and then this was the inverse of f of x. So let's go back to our little graph at Desmos, and let's type in 3x minus 10. There it is. I'm going to have to move the screen so you can see. But again, I can play with my little line over here. And well, the dots, there they are. That's the inverse. So this is my original, 3x minus 10. And then this red line was the inverse of that, x plus 10 divided by 3. And you might have noticed something also with the inverse, that basically we have the opposite, because remember, inverse meant to reverse the action of the graph. If you look here, instead of a minus 10, it was a plus 10. And instead of a multiply by 3, it was a divide by 3. So there, we're reversing all the actions of the original graph. So it's very simple. How do we take the inverse of this? Well, first thing you can say is, whoops, let's change that pen here. Christmas. First, going to write y equals 3x plus 5, because the definition of an inverse is to switch x and y. All right, so x equals 3y plus 5, and now solve for y. X minus 5 equals 3y. X minus 5 over 3 equals y, and then we're going to write it in function notation. X minus 5 over 3. Here's f of x, and then this is the inverse of it. All right, example 3. How do we take the inverse of this? Y equals 3x squared. All right, I'm going to switch x and y. X equals 3y squared. And now I have to solve for y. X over 3 equals y squared. And now to undo a squared, we square root. So the square root of x over 3 equals y. Now here is a little bit of a conundrum. You have to listen carefully, well, not listen carefully, read carefully. Notice we started off with a function. 3x squared is a parabola that looks like this. If I come over to my little Desmos and I type in 3x squared, that's what I get. There it is in black, and there is my lovely black point moving along it. However, look at its inverse. Its inverse is not a function. See what we solved for? If I were to write that, that is x divided by 3 raised to the 0.5 power. See what happens? I only get half of it. There's my original. There's my half. Why is that? Be careful in what they ask for. There's a difference between inverse and there's a difference between inverse function. You can take the inverse of anything. It doesn't always turn into a function. So if I wanted to turn this into an inverse function, this is my answer. If I wanted to take the inverse of it, then I would put that plus or minus there because I can go on either side. But for the most part, New York State teaches that they only want the inverse function. So that means you can't have an inverse which does not become a function. So here's your summary. This is what I'm trying to say. You can take the inverse of anything. When you create an inverse, it may or may not be a function. Read carefully. The question may ask for an inverse function. At that point, you have to realize what you created needs to be a function, so you may have to make an adjustment for it.